Effect of CPU parameters is monitored by embedded sensors. What is a sensor? A sensor is a device that detects and responds to some type of input from the physical environment. It is basically a converter that measures a physical quantity and converts it into a signal which can be read by an observer or by an instrument, mostly electronic. Sensors are used in everyday life like touch-sensitive buttons, optical mouse, smartphones, etc. Our bodies also have sensory organs like eyes, ears, nose, which sense sight, sound, and smell respectively. Just like our biological sensors, there are several sensors embedded into the CPU, motherboard, and other peripheral devices as well. These measure parameters like CPU temperature, fan speed, memory usage, clock speed, CPU voltage, etc.
Now let us look at the temperature sensor. Why does the CPU heat up? Microprocessors heat due to the Joule effect, that is the process of transforming electrical energy into heat. How this can be harmful? The rise in the temperature of the CPU can lead to its reduction of lifespan, random freezes, random resets, and eventually the CPU can get burned. How heat is dissipated? The heat transfer path may be from the component to a printed circuit board, that is a PCB, to a heat sink, to airflow provided by a fan, but in all instances eventually to the environment. Heat sink. As can be seen in the diagram, heat sink is a component designed to lower the temperature of an electronic device by dissipating heat into the surrounding air. Now let us look at a video where the heat sink has been removed. As we can see, the person pours some water on the processor chip, which instantly boils away. In fact, the temperatures are so high that an omelette can also be made on the chip. How sensors work? Each core on these processors has a digital thermal sensor, DTS, that reports the temperature data relative to TJ max, that is, the safe maximum operating core temperature for the CPU. As the CPU heats up, the distance to TJ max will decrease. If it reaches 0, your processor will start to thermal throttle or slow down. So maximizing your distance away from TJ max will help your computer run at full speed and more reliably too. Now let us look at the softwares that we've used during the analysis for Windows. Prime 95. It is used for putting the CPU under 100% load. Core Temp. It is used to monitor frequency and core temperature of the CPU. Speed Fan. It is used to monitor CPU usage and fan speed. CPU ID Hardware Monitor Pro. Used to monitor voltages, temperatures and fan speed. Finally, we will now see how the fan speed and CPU temperature vary with each other while simultaneously changing the load on the CPU. We will also note the change in frequency of the processor during this analysis.
The softwares which have been used for this analysis are Prime 95, Core Temp, Speed Fan, and CPU ID Hardware Monitor Pro. We will be using an Intel Core 2 Duo processor for this analysis. Before starting Prime 95, the CPU is at minimal load. In Core Temp, we can see that the frequency is 2393.99 MHz. TJ max is 105 degrees Celsius and Core 0 temperature is 54 degrees Celsius and Core 1 temperature is 56 degrees Celsius. In Speed Fan, we see that the CPU usage is 27.3% and the fan speed is 3327 RPM. We can also check the graphs for the core temperature and fan speed using this software. In CPU ID Hardware Monitor Pro, we can also check the core temperatures, which is Core 0 at 59 degrees Celsius and Core 1 at 48 degrees Celsius. We can also check the airflow temperature, which is 43 degrees Celsius. Other than that, we can check the voltage provided to the laptop and the amount of charge left in the laptop as well. We will now start Prime 95 to put the CPU under 100% load. On doing this, we notice that the frequency has increased to 2527 MHz. Core 0 temperature is now 66 degrees Celsius and Core 1 temperature is 67 degrees Celsius. In CPUID Hardware Monitor Pro, we note similar changes. The Core 0 temperature has risen to 63 degrees Celsius and Core 1 temperature has risen to 65 degrees Celsius. The airflow temperature is now 45 degrees Celsius. In speed fan, we notice that the CPU usage has reached 100%. The fan 1 speed is 3972 RPM. We will now use fan speed to generate graphs for the core temperature and show its variation with the increase in the load on the CPU. Here we see that the core temperature has risen as load was increased. We will do the same for fan speed. Here also we see that the fan speed has increased as the load had been increased. After stopping Prime 95, we note the following changes. In core temp, the frequency is now 2393.96 MHz. Core 0 temperature has dropped to 54 degrees Celsius and Core 1 temperature has dropped to 53 degrees Celsius. In CPUID Hardware Monitor Pro, we see that the core temperatures have dropped and the airflow temperature has dropped as well. In speed fan, we see that the CPU usage has dropped to 29.8% and the fan 1 speed is 3310 RPM. If we see the graph for core temperature now, we see that the temperature has dropped after the load on the CPU was reduced. We notice the same for fan speed as well. The fan speed decreases as the load on the CPU was removed. We have used the following softwares for monitoring the core temperatures in Linux. LM Sensors. This is used in command line interface. X Sensors. This is used in graphical user interface. LM Sensors. We first install LM Sensors using the command sudo apt-get install LM Sensors. LM Sensors now detects the sensors using the command sudo sensors detect. After all the sensors have been detected, run in terminal sudo service module init tools start. We now run LM Sensors in terminal using the command sensors. Here we can see the core temperature and the adapter temperature. X Sensors. We install X Sensors using the command sudo apt-get install X Sensors. We now run LM Sensors in terminal using the command X Sensors. Here we can see the core temperatures and the adapter temperatures in GUI, that is graphical user interface. Variation of CPU core temperature with varying loads. For this, we run X Sensors and LM Sensors in terminal together. Along with that, we also run System Monitor. When the CPU is under no load, we see in LM Sensors that the Core 0 temperature is 48 degrees Celsius and the Core 1 temperature is 46 degrees Celsius. In X Sensors, Core 0 temperature is 49 degrees Celsius and Core 1 temperature is 46 degrees Celsius. In the System Monitor, we see that the CPU 1 usage is 12% and the CPU 2 usage is 5%. When the CPU is under 100% load. To put the CPU under 100% load, we run an infinite loop in terminal. We use the following shell script to do so. When the CPU is under 100% load, we see that the core temperature increases. In LM Sensors, Core 0 temperature is 65 degrees Celsius and Core 1 temperature is 67 degrees Celsius. In X Sensors, Core 0 temperature is 69 degrees Celsius and Core 1 temperature is 70 degrees Celsius. In the System Monitor, we see that CPU 1 usage is 100% and CPU 2 usage is 92.2%. We can see a sharp rise in the corresponding graph as well. When the load is removed from the CPU by stopping the infinite loop, we see that the core temperatures decrease. In LM Sensors, Core 0 temperature is 55 degrees Celsius and Core 1 temperature is 54 degrees Celsius. In X sensors, core 0 temperature is 53 degrees Celsius and core 1 temperature is 52 degrees Celsius. In the system monitor, we see that CPU 1 usage is 12.1% and CPU 2 usage is 7%. We can see a sharp decline in the corresponding graph as well. Therefore, we can conclude that as the CPU load increases, the core temperature also increases, and as we reduce the load, the core temperature decreases.
Let us now look at the accelerometer sensor. The accelerometer is a device that can measure the force of acceleration, whether caused by gravity or by movement. It can therefore measure the speed of movement of an object it is attached to. The accelerometer is vibration, shock, tilt, and rotation sensitive. Accelerometer uses. It is used in newer mobile phones, smartphones, tablets, and laptops to increase user experience, and are also used to play motion sensing games and applications. Hard disk protection. In recent laptops, it is used to detect sudden impacts or falls and pushes back write heads on HDD to prevent data damage or loss. It can also be used to detect earthquakes. The Quake Catcher network uses a software that taps into the accelerometer sensor's reading, transmits them over the network, and uses that data to detect earthquakes. Now let us see how an accelerometer works. This video clip shows how an accelerometer is being used in a mobile phone. Type of accelerometers. Piezoelectric accelerometers. These contain microscopic crystal structures that get stressed by accelerative forces, which causes a voltage to be generated. Capacitive accelerometers. If you have two microstructures next to each other, they have a certain capacitance between them. If an accelerative force moves one of the structures, then the capacitance will change. Add some circuitry to convert from capacitance to voltage and you will get an accelerometer. Piezoresistive accelerometers. These work by measuring the electrical resistance of a material when mechanical stress is applied. They are preferred in high shock applications and they can measure acceleration down to 0 Hz. These are some of the references that we have used. Thank you.